Hello and welcome to this week's Ask Joe webinar. The subject this week is going to be on the Spectra Geospatial Survey mobile application for the Android platform. And the simple to use Android-based program allows field personnel to collect and stake out data in a multitude of fashions. And while Spectra Geospatial does offer a variety of some rugged handheld field-ready Android devices, it'll run on any Android device that you may have. So presenting today is Joe Sass. After the presentation, please ask Joe your questions about the Survey mobile program. And a little background on Joe, he is our channel development manager. And as a field application engineer, he is a liaison for us between the product marketing, sales, and engineering. He's got a degree in geography. It blends nicely with his passion for land surveying. And since 1988, he has been active in the California Land Surveyors Association, and in 2004, he began representing us with the RTCM Standards Organization. And he currently sits on the board of the RTCM directors and is very involved with that as well. So with that, I will turn it over to Mr. Sass, and thank you for joining us today.
Thank you, Mr. Binder. Hello, good morning, good afternoon, good evening, wherever you may be right now. Thank you for attending today's session about Survey Mobile for Android. Why isn't it going? Okay, so this is the main menu. It's a rather simple interface, but it's deceptive in that way, in that it's got a lot more than appears on the surface at first view. It's Android version 4.3 and higher compliant. In many markets where price is everything, this is being run on cell phones, and that's perfectly fine. Anybody can install the software and run it as a trial version. You just can't store a lot of data. So anybody who might be interested in test driving it, it certainly is available, and you can install it on any Android device you happen to have. This is primarily, in my mind, a GNSS data collection tool, but it does support our Nikon and Focus mechanical total stations. At the highest level of the software, I would say it's up in that upper right-hand corner where we decide whether or not we're going to use the internal GPS of the device we're using, we're going to use a total station, or if we're going to use GNSS. If we're connected to a GNSS receiver, that icon in the lower right-hand corner will be green, as you see. So you can see that we are connected to an SP60, and at the top there, connect rover base status properties. That's really where we configure our receiver and tell it what it's going to do. Are you going to be a base, or are you going to be a rover? Connect to it, and then I'm a base. Connect to it, and then I'm a rover, and then you check the status, basically. Is my workflow. Usually most of these screens, there's a back button, gets you back, and you keep on hitting it sequentially until you get to the main menu. This is what it looks like. You can see the toolbar at the bottom looks different for a total station, and we are connected to a total station in this example, versus the toolbar at the bottom when we're connected to the GNSS, and then the toolbar if we're connected to the internal GNSS of the receiver we're using. In the Spectra Geospatial realm, this product is good not only with the Nikon and the Focus mechanical total stations, but with the SP20, MobileMapper 60, MobileMapper 50, and then with those devices hooked up to an SP60, SP80, SP85. There are some shortcuts, keyboard shortcuts, as I mentioned, the back button to get you back sequentially to the main menu. Also on the Android device itself, if you hit the back button or the enter button on your Android device and do an extended click on that, it will get you to the main menu without going through the sequences of steps that it might have taken you to get into the routine you're working on. There are also some keyboard shortcuts. For instance, when you're surveying from the map screen, we do have that available. Then you're going to be using some of the Android buttons on the device you're using, such as the volume down and volume up. Survey Mobile ties the coordinate system or the site calibration to the job. They are married together. And so one goes with the other. You can change it. I'm not sure how it handles those recalculations, but you can. So here you can see that I've got a list of my jobs, and then the jobs may or may not have this site calibration attached to it. It would be a coordinate system definition. Here you see that it supports the broadcast RTCM. It's not a very common network provision in the US. It's becoming more common in Europe. You can choose an existing coordinate system. Interestingly, if you choose a coordinate system that's not in the device, it will download the coordinate system parameters from the Trimble Geodetic Library, or you can actually pencil in or key in your own coordinate system definition. I'm not sure I really care for the nomenclature here, and you can go back and forth between them. But if you plan to work with GPS and you plan to be in a site calibrated condition where you're actually occupying ground control and comparing it to the GPS, in that situation, you would choose no datum, no projection as your coordinate system. If you're using a total station, you just want ground distances, that's scale 1, that's when you would choose scale 1. So in my mind, scale 1 parameter or coordinate selection is for total station, and then everything else is for my GNSS. Again, if I don't have these coordinate system parameters installed already, it will download the geodetic library from Trimble's website. I'm going to ignore what you see at the bottom called transitions. I don't understand them. I really did try to figure them out. I think that they might be deprecated in the software, and I don't think they're practical, at least not in the current state that they are. So I'm going to ignore them today, and that will be the extent of my conversation on transitions. But really, Survey Mobile is quite easy when it comes to using arcs and points and lines. And here you can see examples of all of those where I created a line between points 305 to 306. I created an alignment that includes straight segments and arcs going left and right. And I also have points out there that were just collected independently. The plus sign or the crosshatch you see there next to point 101, that is the location of the GNSS at that moment, or the rodman if I were in a total station environment. We can add and we can store receiver profiles. Here you see I've got 2 different SP60s that have been selected or profiled, and I can select from either of them. And to connect to these receivers, it's the standard Bluetooth workflow. I know that may not be acceptable to some of you as far as me just covering it like that, but there's nothing special about the Bluetooth workflows, and it varies very little between receivers or total stations. Here you can see the receiver connect tab, where I'm either connected or disconnected. Notice that when I'm connected, the receiver down in the icon in the lower right-hand portion of the page is green. And when I'm disconnected, it's got the red X on it. Also notice that I'm connected to a receiver there on the page on the left. I'm connected to a receiver whose battery is almost dead. So good indication there that I need to change my battery. I don't need to read this for you, but we support all of the GNSS configurations that are available with that receiver. So for instance, you're not going to get RTK radio choice if you're using an SP20, because the SP20 does not have that capability. But if you're using an SP60 or an SP85, we will show you those capabilities, including long-range Bluetooth if you're using an SP60, because we understand that it's got that capability, excuse me. I went backwards. So UHF base and rover, it can access the internal UHF radio that the SP60 and the SP85 possess. Here you can see I've selected a radio channel. and I can hit OK. Additional programming parameters, you still need to use the ADL conf software, but you do have access to the channel frequency list. Network rover. So in this instance, we're going to use the internet that the cell phone or the data collector itself, the MobileMapper 60 provides. And this is the address, username, password, and mount point for the end trip that this is getting prepared to connect. Bluetooth based rover, especially useful with the SP60 out to maybe 400 feet, 120, 130 meters pretty easily. Here under the settings, manage, the big button manage, second button settings, you get in here where you can set your tolerances, rather loosey-goosey here in this example, as we would say, number of decimals you want in your display, and how you want your. We can have background mapping, so you can have a background map behind your data, DXF only. And in this example, you will see that you place the DXF file into the import folder that's on the surveymobile.droid subfolder. So that's where it goes. DXF is unitless, so you must tell the program what units the DXF, and you could be running a job that's in feet, but if the DXF is in meters, you can tell the program that. You can orient the DXF to your job. In this example, I've chosen DXF Cal and DXF Cal 1 as my points to compare with DXF_0 and DXF_1. The second point pair that you see is a rotation point only. There is no scaling involved. So it's simply the first point is going to be the hinge point, and the second point is the backside or the orientations, so to speak. Lots of satellite information. I'll let you just look at that for a moment. The purpose of this session is not really to teach you how to use the software, but more to make you aware of what the software possesses. That's, in my mind, that's what I'm doing. You get very detailed information on each satellite under the list function of the satellite status pages. I've gotten to this page by pressing on that satellite icon at the bottom, the second one from the left. And if I'm doing a GNSS survey, this is my GNSS survey menu. Obviously, if I'm doing a total station type survey, then I'm going to have different choices. I'm not going to have static or stop and go. I might have rounds or things like this traverse. If Survey Mobile knows the receiver, which it will at SP60, SP80, SP85, and I think maybe SP90M are the supported GNSS receivers right now. It knows how to convert a slant height to a vertical height, or how to adjust for the UHF antenna, which only in my, oh, I'm sorry, this is for the UHF antenna with the extension on, which adds another 5 centimeters. Here's what the survey data collection screen looks like. Once you give the point a name, it will automatically increment. Once you give the point a code, it will automatically retain. And once you define a number of epochs to collect on each point, that will be persistent until you exit this page. When you re-enter this page, you will have to redefine the number of epochs that you want for the points. What I did to get to this map page, let me go back one page, is I clicked on the map icon that's in the upper right-hand corner of both of these pages. That takes me into what we call the map page. And from the map page, I can do my data collection as well. Use the down volume button to actually begin the data collection. And then you can hit the up button to stop and store, or you can hit the down button just to stop it. This is what it looks like in the middle of a data collection session. So in this example, I'm 5/30ths of my way through the data collection. I've specified that I want 30 epochs, and it's collected 5 of them at this point. If I click on those horizontal lines in the upper right-hand corner of the display, it will break out my legend, which then tells the user what each point class is. It can get in the way, so you click on it again, it goes away. If I click on this bottom button that has the finger hitting the target, I get a choice of snaps that pop out. And so this snap you can see is saying snap to the center of a line, and snap to the closest end of line, the tangent intersections of an arc. So this one may be a little bit confusing. It's actually that DXF arc 1442, etc., is actually the tangent of the smallest arc. It's not supposed to be a point on the line of the second arc. It's actually the result of a computation there. Radius points of an arc, create points anywhere along a line or an arc. And I can also then delete all of these points. As with other programs, if I want to save any of these temporary points to the job, I just do an extended right mouse click on the point, and I will be given the option to save it. In the GNSS side of things, it's a little bit different than on the total station side, the offsets. So the offset was probably computed as the inverse between 2 points, which can be done. I can say 2-1, and the program will compute the azimuth between points 2 and 1. And again, I'd point out just for clarification that you see a little crosshair sticking out underneath point 303 is the actual GPS position, which you can see is a fixed position in the state plane coordinate system defined in meters at the top. Continuous surveying can be by time or distance parameters, and you can define what the starting point name and or codes will be for the points. We support both the stop and go method, which basically turns on logging, stop and go, turns on the logging of raw data, but then puts individual fields for the stops in that data where you're actually collecting points, data on points of interest. And of course, we do static survey, which is just basically this is kind of not necessary unless you definitely want to get point codes and define various intervals, because all of my receivers can log data by pushing buttons on the receiver itself. Point staking, you can see how very good I am at point staking. I'm right on top of my target within a centimeter vertically and 4 millimeters horizontally in 2 directions. I've asked product marketing to maybe look at these words and adjust them. So that's under consideration. Here, line staking, I've defined a line between points DWS to DWW. That's my typical nomenclature. I could have called it anything I wanted. And it tells me what my offsets are and where I've got to go to get to that point here. Arc definitions, 3 different ways to define an arc in the software. Arc staking, I choose the arc, and then I get directions to the arc. You can see I'm 35 meters away, 35.6 meters away from the target point, which is actually a station on that arc. I want to stake out station 0+4, and right now I'm at 0+7 with a big offset to the right. Here we're going to create a job with no datum, no projection. I can show you how the site calibration routine works inside the program. I then import a group of control points that I will use to calibrate against. Those control points were in the form of a text file that I placed inside the import folder, yellow local-6 points.txt. They come in the form name code northeast elevation. Once I've got those points inside my job, I'm going to do a horizontal and vertical adjustment. It's a plane transformation on inclined plane. That's my only choice there. So here you can see I've chosen a point called SW. I chose it by clicking on these horizontal lines right here, and it pulls up the value of SW. And then when I get over here, I click on this button here, or actually this button here, and it actually then allows me to start the GNSS data collection on point number SW. Once I've gotten a comparison between this northing and easting and this latitude and longitude, this elevation and this ellipsoid height, I hit the add button, and I've now added 1 point to my site calibration. I do that repeatedly until I have enough points to satisfy my requirements. And when I click on this eyeball looking icon at the top of my page, I will then be able to see the point pairs. Here on the far right, you can see a list of point pairs. I've got DWS to DWS GNSS, base to base GNSS, SW to SW GNSS. There probably are more below that we can't see here. And each one was done by selecting the vertical control point, or the 3D control point here, and choosing another point here. I can choose a point here. If I go out and make all of my measurements, I can then choose them from a point list. I can manually key them in with the plus button, or I can physically occupy them by clicking on this icon here. Once I've into this point pair list, I can have it calculate my calibration, or I can delete point pairs that might be causing me problems. How would I know a point pair is causing me problems? Is because there's a residual page that allows me to see individual contributions to the error. So in this example here, even though it's not significant, there is the most amount of error being contributed, it looks like, by point pair number 5. So I might want to go back, and I might want to delete point pair number 5 and then recalculate. So I have this kind of control inside the software. This page here is just showing me general information about the site calibration, whereas this actually digs into the individual point pairs. Looking at mechanical total stations, it's very similar to the GNSS in the way you connect and disconnect. There are not as many buttons up here as there were on the GNSS, and the targets down here are a little bit different, showing you a connected state and a disconnected state. And this is how I would get in and control my prisms, and this is how I would get in and control my laser pointer. And then again, this is battery information on my total station. Again, I use this term standard Bluetooth workflow. On most total stations that I have, you have to activate a Bluetooth utility on the total station itself. And of course, you would have to do that to connect this software to your total station as well. Am I doing a new total station setup, or do I want to do the same as I did the last time? Even if I say the same as I did last time, I still have to fill out some fields. So am I going to use the prism or reflectorless? And if I'm using a prism, what are the constants, right? And if I'm using a prismless, do I want to have the laser pointer turned on? So in this example, I'm going to do a known point setup, but I could also do a known azimuth and resection as well with the software. These are the fields that I must fill out. In today's state, you must put in a barometric pressure, and you must put in a temperature, and whether or not you wanted to use curvature and refraction. You can do angle sets, rounds, I guess a lot of people call it, and do multiple angle sets. You could do a backside azimuth only, or you can do a known point backside. This is just access to my point manager. How do I want to set it up? How do I want to select? This is the selection of where I'm setting up my total station. How do I want to define that point? Do I want to select it from a list of points? Do I want to select from the map, or do I want to add it from scratch? So if you'll remember the GNSS surveying page, it was different. I think the only thing in common, maybe the point, line, and alignment stakeout. Call it topo point survey here. Some of the map settings, do I want to automatically have it traced to me, or do I want to be able to walk off the page? You can see that we can have real background imagery. This is a choice here for Trimble Map View in the background of my map page. This is the data collection page. I'm going to collect point number 101 with a point code of topo by hitting measure. These are the offsets that are supported inside Survey Mobile. Support rounds, phase 1, phase 2 measurements, multiple sets. Total station staking is a little bit different than it is with the GNSS. Here you can see how it's giving me directions forward, leftward, downward. I can stake lines, arcs, and as I said, I'm ignoring transitions for today's discussion. So I need to name the line. Here you can see I've got a start point and an end point. It's an interval of 25 centimeters, and I want to start at station 0 plus 0, 0. Alignment staking is different from line staking in that I can join multiple segments together, right? In parts of the world, they define roads by what they call intersection points. And in most of my world, we define elements like straight segments, arcs, et cetera, vertically, horizontally. So we have both capabilities within the software. Here's just a display of an alignment I quickly built, composed of 2 arcs and 3 segments, 3 line segments. There are some COGO tools in the software as well. I don't need to read these to you. I'll let you have a moment to read them yourself. The import dialog, these are the acceptable formats for data to come into the software. If you were doing road design, the RXL would be the desired format. You're exporting data from Survey Office or Trimble Business Center. I would imagine JXL is probably the best. You notice it in AutoCAD since DXF is supported. And under the point menu, you see that we have a default template. We have 2 other choices, but then we also have a customized template. And the customized template is quite powerful. We do a really good job on this. Here it is on the far right. Everything in that upper part of the page will be imported or exported as long as that field exists. If I don't want it, I just drag it off and I drag it to the bottom part, and it won't be part of the export or the import. Very, very convenient customization tool for getting data in and out of the software. RXL, as I mentioned earlier, are the preferred roading format. Then goes into the import folder. And that is it. I did have the software hooked up, but it's not running right now, it doesn't seem. And I was going to offer to show things live, but it doesn't seem to be working right now. Let me just have one more. There were a couple of things I did want to show you. First off, I'm using this software called Visor to be able to display my Android device. And I wanted to show you on the device itself. Let me open it up here. If I drag down from the top, you see that it says Android system USB for file transfer. And if I tap for more options, the default here is to charge this device. And so if I'm trying to transfer data back and forth between a computer and the Android device into those import and export folders like I talked about earlier, I need to make sure that I drag down from the top and choose the transfer files method so that I can do that. I also wanted to, let me see, get into the survey menu here, point survey. I'm not connected. I'm going to go down here. I'm connected. I'm going to go rover. And I'm going to say start the RTK stream. So let me stop it. I started it an hour and a half ago, so it's probably battery. RTK is now started. Come back over here to status. You can see right now we're SBAS and now we're fixed. Within a moment or two, we should get information about our base station. That information is not broadcast as often as the RTK corrections themselves are, but before long, it should populate. Anyhow, we're in an RTK fixed solution. If I go to survey right here, I go to my map page. This is my map page. If I go to this bottom button, those are my snaps that I referred to earlier. If I go to my layers here, that's going to show me my background map, and this is where I would import it from. If I go to, let me see if I can find it. Manage data points. And I know that I've only got a few points listed here, but if I had many, many, many points, I could hit this filter button, which is in the upper right-hand corner, right there. And here I can filter the points by staked or measured or defined or imported or calculated. I can go through the library and say it's got to be in the control position, a control point, or point solution, the type of solution that it was. There's quite an extensive point filter so that I can actually hone in on the points that I care about and discard the ones that, for the sake of the query at the moment, I don't care about. I also just wanted to show you how also if I create a new job, let me give the job a name like demo, and I choose a coordinate system, I can key it in, right? Or I can choose it from a list. And if I choose it from the list, let's say it's Australia GDA 94, this is that warning that I told you Survey Mobile would pop up, allowing me to go ahead and download that file. So I'm not caught without an ability to do what I need to get done. And my point is not to let you watch this download, but to let you know that most Android devices have internet, either through Wi-Fi or cell phone. And this is allowing you to get the data you need when you need it. So with all of that being said, I think I've covered the points that I cared to cover today, and we can open it up to any questions.
Thank you, Joe. We did have one question come in regarding the Focus 35 robot. Will the Survey Mobile program run that?
No, mechanical total stations only. Limited to my mechanical total stations.
All right. Well, if there are no other questions, we want to thank you for joining us today, and appreciate you coming for this week's Ask Joe. If there are any questions that come about later, please reach out to either Joe or myself, Joe Binder or Joe Sass, at Joe_Binder@Trimble.com or Joe_Sass@Trimble.com. Thank you much, and we look forward to seeing you next week. Bye-bye.
Thank you. Bye-bye.